Hello guys, welcome to our video. Today we will discuss about adapter design pattern. So by definition, adapter design pattern actually works as a bridge, and it works as a bridge between two incompatible interfaces. So this type of design pattern comes under structural design pattern. Why? Because this pattern combines the capability of two independent interfaces who are incompatible in nature. What is the meaning of this? Let's try to understand with a real-time example. Suppose we have a British wall outlet, and this outlet is having some power extensions interface. So through this interface only, it exposes power to a device. And the device has a plug point. This is, say, for example, a standard AC plug point. So the plug point, whatever interface the plug point expects from the outlet or from the wall outlet device that are incompatible. That means the interface of this British wall outlet and the expectation of this AC plug point uh, are different. They are different. So you cannot make change on this AC plug point, right? And you also cannot change in this British wall outlet, right? Because it is already installed, and this is you have something bought from the market. So if you want to make them compatible, you need an extra device. And that is basically our adapter pinpoint. So this adapter plugs or fits well with this British wall outlet without jolting its own functionality, as well as it offers an interface where this AC plug point is too comfortable. And that's why it bridges between these two interfaces and works as an adapter. So it creates some difference on the structure. So it comes under the structural design pattern. So that's a real-time example. Now, if we just go to the next slide, we can see that here, suppose we have our existing system, and this existing system, when we are saying that this is an existing system, we have an expectation that we won't make any change on the source code of existing system or on the structure or interfacing layer of the existing system. We have some vendor classes, and these are having a special interface. So you can see this curved line is an interface of this vendor class, and this is a shaped triangular kind of shaped is kind of an interface of this existing system. So they are incompatible in nature. And we want what our expectation that we won't make any change over here. We won't make any change over here as well, but we would like to work them together. So we need an adapter kind of thing, which will, help us to join these two systems, to talk these two systems, to combine these two systems without disturbing their own functionality, right? So if you just see in this here, the adapter acts as a middleman by receiving requests from the client and converting that request so that it becomes or it makes sense to the vendor class, right? So that is going to be the responsibility of adapter. We are not overburdening, or we are not making any changes on these two systems. That means we are following open close principle. Open close principle says that we cannot make change on the existing code, rather we can extend it, right? So it's closed for modification. So we are not doing any modification over these two uh, segments of different systems, right? So this is in this case, see, you can see like the new code has been introduced as an adapter, which helps in adapting or works as a middleman, and it helps in these two classes. Now, if we just try to find out, like here, the client, you can say like the AC plug point, and he's sending request to the adapter. So this adapter brings an interface which is compatible to the client. So this is the target interface. So you can, from the code perspective, from very high level, you can think that we can define an interface which is compatible to the client or customers, right? So the customer can easily talk to that interface, and we can have a class which will implement that interface, and that class will bring the functionality from the adaptee, which is basically our wall mounted plug point, right? So this plug point has a totally different interface, and that is not compatible with the client. So we can bring the functionality over here in this adapter by uh, creating an instance of adaptee over here, and we can call the functionality which we want, which our client want. But in this whole mechanism, in this whole story, the client doesn't know about adaptee. So the client is decoupled from the adaptee. So that's the another thing which we want to maintain over here through this design. So if we just go and try to understand the code base, suppose we have an interface and this is a dark interface. So dark interface can quack and fly. So there are two methods, public methods in this interface by default. So the methods are public in interface. So this, we need to implement this, this interface. So there is a class called mallet duck which implements this duck. You can see like we have just given a print statement over here that is quack. And in case of fly, we have implemented this fly method over here, and we have given a print statement that I am flying. This is a very, very simple implementation. Now let's think there are another interface, which is the turkey interface, right? And there is a wild turkey class which implements this turkey interface, where the turkey interface has two methods. One is gobble, another one is fly. So in case of when we are implementing it, we are saying gobble gobble, and we are saying I'm flying a short distance, right? So we can see that two class. One is mallet duck class, which is having a dark interface, and another one is wild turkey, which is implementing the turkey interface, and both these interfaces are incompatible in nature. So if this class wants to talk with this class, they cannot talk directly. We need a middleman. So how that middleman comes into the picture and how they are handling it, that is very important. So before going into that part, we have to know who wants to talk, who wants to. If we just go back to this who diagram, we can say like who wants to give the request. Whoever is trying to give the request is going to be the client. So we have two classes. One is mallet duck, another is wild turkey. So who is going to send the request? He is going to be the client. Now let's understand that from this driver code itself. So from the driver code, and we will come back to the adapter, how that adapter has been made. So from the driver code itself, we can see like the mallet duck has an object that's a dark object. Another one is the wild turkey, which is having the turkey object. So what is happening over here? We have written an adapter, and the adapter is implementing the dark class. Adapter is implementing the dark class. Now, if we go to the slide which we have defined over here, the adapter can talk to client only when the client is, I mean, if the client is comfortable, if the client is comfortable with the target interface, and if the adapter implements that target interface, then only client can talk to adapter directly. So if we go over here, we can see that the adapter class is implementing the dark interface. So if we just come over here, and the slide which we have earlier, dark is an interface, turkey is an interface. So dark is the interface where the client is basic. This is the target interface with whom the client is comfortable to talk with. So the adapter basically implementing this dark interface. Now, whenever we are implementing the dark interface, that means whatever the method has been defined over here in this interface needs to be implemented in the adapter class. So the methods are quack and fly. So if we come over here, you can see like we have two methods. One is quack and another one is fly. And when we are implementing quack, we are borrowing the method, we are borrowing the function which the tarkey is having. Tarkey is basically adaptee over here. The tarkey is having the gobble method. We want to wrap that method under this quack method. Where is that one? Yeah. So you can see like we have created an interface over here in the adapter class, and sorry, we have created an instance of Tarkey class over here, and that too in the constructor. So this is the instructor. So this is, you can say like constructor injection, or injection is happening through the constructor. So we are having that instance along with us, and in the quack method, we are calling the gobble method directly with the help of Tarkey interface. That means with the help of adaptee. So in this way, we are wrapping the adaptee's functionality, and the client code doesn't need to worry about this adaptee instance. So the client directly called to the adapter, and here you can say like I am providing the Tarkey instance. Yes, you are providing the Tarkey in a instance, but that instance can be injected through dependency injection, and we can fine tune the responsibility. We can make the clean the responsibility more, and we can make it more cleaner. But the adapter is having dependency with the Tarkey interface or the adaptee object, but the client doesn't have any objection or any dependency with the adaptee directly. So now if we call that Tarkey, which is basically Tarkey adapter, if we just call the Tarkey adapter, so Tarkey, if you just see like the Tarkey adapter is having these two methods. And if we say like with the help of this Tarkey, so if you can see like the test duck method, which is taking the duck in the duck instance. Duck is basically the client instance. So child class instance, I mean, this is parent class reference can point to the child class object. So interface can point to the any object which has having its own implementation. So this duck is basically, if you can see like the Tarkey adapter instance has been provided as an argument in this class, in this method. And whenever you are saying like duck quack, it will give us a return like whatever we have written in gobble method of the adaptee interface, right? And in case of fly also, we will be having the same thing, whatever we have implemented over here. We have implemented Tarkey.fly, and that is also 5 times. So that is like the adapter pattern. It becomes a bridge. It also, you can say like work as a wrapper. So if we just here follow a few points, like the client makes a request to the adapter. So that is the thumb rule. And how that request will be happening by calling a method on it using target interface. And the adapter translates that request into one or more calls. Here actually we have seen that one function has been called adaptee interface, and he can call it through adaptee interface. The client receives the results of the call and never know there is an adaptee. So the client doesn't know about adaptee. It doesn't have any dependency of adaptee. So in the notes section, we have also mentioned that client and adaptee are decoupled, and that's the biggest thing. Now, if we just see the class diagram, here you have the client, here you have the client interface. So directly adapter implementing the client interface, and this client can talk to client interface, or client can consume the adapter very easily because client is comfortable or compatible with the client interface. Now in the adapter class, you can see there is an instance of service class. Service is basically our adaptee. So you can see like this is in an instance of adaptee. It's negative means it's a private instance, and that is an instance of service class. So if you call this method like service method, you can see like adaptee.service method has been called over here and has been wrapped in this adapter class. So whenever the client uses this instance, it doesn't know about the service class, and that's all about this pattern. Now, if we just see like the sequence diagram, the client is sending request to the target interface forwarding that request to the adapter class. Adapter and adapter class is basically implementing the target interface. And after that is it's having an instance of adaptive method. So specific request, whatever the request has been made to adaptive class, that is being called, and the response, whatever the response is back, is sent through these layers to the client. So that's the sequence of calls. So if we talk about the pros and cons, as we mentioned earlier also, like the single responsibility principle is being followed over here. We are not making any changes to the adapter and adaptee. Both code are getting intact, and it is very important. That's why open close principle is not getting broken over here. Another important thing is single responsibility principle. You can separate the interface or data conversion code from the primary business logic of the program. You can have multiple adapters. You can have multiple adapters. And what is the disadvantage? The disadvantage is the complexity. Complexity of the code gets increased over here because you need to introduce a set of new interfaces and also corresponding classes. So sometimes it becomes not so simpler and not so simpler to handle and maintain. So that's it from our side. If you have any sort of doubt or any sort of comment or review comment, you can, we would like to have we would like to be glad to receive those things, because we want to improve ourselves and we believe in continuous improvement. Thank you so much.